Welcome to the deep dive. Today, we're going to be tackling something that, maybe seems a little dry at first glance, the economics of corrosion.
Hmm.
But, our listeners sent us some really interesting research on this, reports and case studies, even some insights from NASA.
Oh, wow.
Yeah. So it seems like they're really interested in understanding just how much this natural process, well, how much is it costing us?
Yeah.
And, are there any places where we could save money or maybe even find some really cool innovation?
Yeah, that's a really great area to explore. I think corrosion often flies under the radar.
Right.
It's seen as just like a nuisance, like, oh, there's some rust.
Yeah.
But the truth is, it's this like silent economic drain.
Yeah.
On this massive scale.
Yeah.
And it impacts like everything from the bridges that we drive on
Yeah.
to the planes we fly in.
Yeah, for sure. Okay, so before we get into the really big numbers, the costs, can you give us a quick sort of jargon-free explanation of what corrosion actually is?
At its core, it's the deterioration of materials, primarily metals, just due to reactions with their surroundings.
Okay.
It's a gradual process, often invisible at first, but over time it can significantly weaken structures
Yeah.
and then lead to failures that can be really costly.
So it's not just like things looking rusty, it's
Uh,
about their like structural integrity being compromised.
exactly. Yeah.
Mm-hmm.
You think about a bridge, for example.
Yeah.
Corrosion can weaken the steel supports,
Right.
lead to cracks, and then ultimately like jeopardizing the entire structure.
Wow. Okay, that makes a lot of sense. Okay, let's talk numbers.
Yes, do it.
So one of the sources that our listener sent was a 2002 study by the U.S. Federal Highway Administration, and it hit me with a pretty shocking statistic. It said that the annual direct cost of corrosion, just in the U.S. alone, is estimated at $276 billion.
Wow.
Yeah. That's almost as much as like major weather disasters over a similar period.
That is a staggering figure. And I think what's even more alarming is that a large chunk of that cost could be avoided. You see, a lot of industries still rely on a reactive approach to corrosion.
Mm-hmm.
So they're dealing with the problem after it arises, instead of investing in like preventative measures.
Oh, so it's like waiting for your roof to leak before you fix it,
Exactly.
instead of doing regular maintenance
got that.
to prevent the leak in the first place.
Yeah. And that ends up costing a lot more money in the long run.
Right. Okay. So we're talking 276 billion in direct costs. But then there are also indirect costs, right?
Absolutely.
Things like lost productivity and delays and environmental damage.
Absolutely. Those are a lot harder to quantify, but they're likely enormous.
Wow.
So that same FHWA study suggested that the total economic impact of corrosion, including those indirect costs,
Mm-hmm.
could be double that initial figure,
Oh, wow.
so exceeding $500 billion annually.
So that's a lot of money.
It's a lot of money.
Yeah. To put this in perspective for our listener, what does this mean on an individual level?
Yeah.
How much is corrosion costing each of us?
Well, that same study estimated that it cost each person in the U.S. about $970 per year.
Wow.
Now, consider that this is just like the cost associated with things like infrastructure,
Okay.
utilities,
Yeah.
and transportation. It doesn't even factor in things like the corrosion costs that are passed on to consumers in the prices of goods and services.
Right. Yeah. That's actually a really helpful way to think about it.
Yeah.
So even if I'm not seeing the effects of corrosion like every day,
Right.
it's still impacting my wallet.
Yeah, it's a hidden tax that we all pay.
Wow. Okay, so we've established that this is a huge problem,
Absolutely.
but where are we seeing the biggest impacts? So the FHWA study breaks down corrosion costs by industry, right?
It does.
All right, let's get into it. Which industry tops the list?
Well, it's actually the utility sector with an estimated annual cost of $47.9 billion.
Oh.
And a lot of this stems from aging water systems. Corrosion leads to leaks, reduced water quality,
Yeah.
and then ultimately higher cost for everyone.
So all those news reports about water main breaks and boil water advisories.
Yeah,
We should be thinking about corrosion as a potential culprit.
absolutely. It's a major contributing factor.
Hmm.
And I think it underscores the need for significant investment in upgrading our water infrastructure.
Yeah. Okay, that makes sense. What's next on the list?
The second most impacted sector is transportation, coming in at $33.6 billion.
Wow.
Now, most people think about rusty cars, but transportation goes far beyond that. We're talking about aircraft, ships, even like the transport of hazardous materials,
Right.
all areas that are susceptible to corrosion, impacting both safety and efficiency.
So that delayed flight I had last month, Could have been corrosion.
It's certainly possible, yeah. Even a small amount of corrosion on a critical aircraft component can ground a plane for hours or even days.
Right. Yeah, so it is a gradual process,
Yeah,
but the consequences can be pretty immediate.
absolutely.
Okay, so we got utilities and transportation. What else?
Next up is infrastructure, which includes bridges, highways, and pipelines. And that study estimated that corrosion cost this sector around $22.6 billion annually.
Yeah, and this is something we're seeing a lot in the news.
Yes.
Aging infrastructure
Yeah,
and a lack of funding to fix it.
it's a major concern.
Hmm.
We're essentially playing catch up with a problem that's been decades in the making.
Right.
And the longer we wait to address it, the more expensive and dangerous it becomes.
Yeah, it's only going to get worse.
Exactly.
Okay, so we got utilities, transportation, and infrastructure. Those are all pretty obvious targets for corrosion.
Right.
What about industries that might be a little less out in the elements?
Corrosion impacts those too. So take production and manufacturing, for instance.
Mm.
Everything from the pulp and paper industry to food production facilities.
Wow.
They face significant corrosion challenges.
So it's not just things rusting away in plain sight, it's impacting like the quality and safety of the things we use every day.
Absolutely. That study highlighted the pulp and paper industry is struggling with a $6 billion annual corrosion bill.
Wow.
And for the food processing industry, preventing corrosion is critical.
Yeah.
Contamination from corroded equipment could have serious consequences for public health.
Yeah, for sure. Okay, so this is starting to feel like a losing battle. Is there any industry that is immune to this?
It really is a challenge for everyone, even the government. So the U.S. Department of Defense, for example, faces an estimated $20 billion annual corrosion problem.
Wow. So if even the DoD, with its massive budget, is struggling with this, it
Yeah.
really underscores how widespread this is.
It does. But before you start feeling too pessimistic, I want to emphasize that this isn't a hopeless situation.
Okay, good.
There's actually quite a bit of good news when it comes to tackling corrosion.
Okay. Whew. I was starting to wonder if we were just doomed to rust away.
Right.
Tell me more about this good news. What can we do to fight back against this metal-eating monster?
Well, the good news is, with the right approach to corrosion management, a significant portion of these costs can be avoided,
Yeah.
both NASA and NACE. The Corrosion Authority suggests that companies could save like 25 to 35% of their corrosion-related expenses.
Wow, that's huge. Like, imagine what we could do with all that saved money, invest in new infrastructure, research and development, even just lower prices for consumers.
Right.
So how do we unlock those savings? What are some of the most effective strategies for fighting back against corrosion?
Well, there are a few key approaches, and it often comes down to choosing the right strategy for the specific application and environment.
Okay, that makes sense. A one-size-fits-all approach probably wouldn't be very effective.
Right.
So what are some of the tools in our corrosion fighting toolbox?
One of the most common and effective methods is the use of protective coatings.
Okay.
And these act as a barrier between the metal surface and the corrosive elements in the environment.
So it's like giving the metal a suit of armor.
Exactly. These coatings can range from simple paint to more sophisticated polymers and even high-tech ceramic materials.
I imagine the type of coating you choose depends on the specific application and the level of protection needed.
Absolutely. For example, a bridge exposed to harsh weather conditions would require a much more durable coating than, say, an indoor metal railing.
Right. Okay, so protective coatings are one option. What else have we got?
Another approach is cathodic protection.
Okay.
This method uses electrical currents to prevent corrosion. Think of it like creating a sacrificial metal that corrodes instead of the structure you're trying to protect.
So it's kind of like diverting the corrosive forces to a less critical target that's clever. How does that actually work in practice?
Well, you essentially create a circuit by connecting the metal you want to protect to a more easily corroded metal like zinc or magnesium.
Okay.
And this sets up an electrical current that flows from the sacrificial metal to the protected metal, preventing corrosion on the protected structure.
So it's like creating an electrical force field around the metal you want to preserve.
That's a good analogy.
Mm.
And it's particularly effective for large structures like pipelines, underground storage tanks, and even ships.
Okay, so we've got coatings that act as a barrier and cathodic protection that uses electrical currents. Are there any other strategies we can use?
Sometimes the best defense against corrosion is choosing the right materials from the start.
Okay.
We're talking about corrosion-resistant materials like stainless steel or specialized alloys that are designed to withstand harsh environments.
So instead of fighting corrosion after the fact, we can sometimes avoid it altogether by using materials that are inherently resistant to it.
Exactly. And there's a lot of exciting research happening in this area. Scientists are developing new alloys and materials with even greater resistance to corrosion, especially in extreme environments.
Okay, so those are our preventative measures. What about dealing with corrosion that's already happening? Is there anything we can do to stop it in its tracks or even reverse the damage?
One of the most promising advancements is the use of real-time monitoring systems. These systems use sensors to detect the early signs of corrosion, allowing for proactive maintenance and repairs before major problems develop.
So it's like having a tiny detective constantly on the lookout for any hint of corrosion.
Exactly.
Mm.
These sensors can measure things like changes in pH temperature and even the electrical resistance of the metal, all of which can indicate the presence of corrosion.
That's incredible. So instead of waiting for something to break or visibly rust, we can get those early warnings and address the issue before it becomes a costly problem.
Precisely. And that proactive approach can save companies a lot of money in the long run.
Okay, so we've covered some of the main strategies for managing corrosion, but I'm always a fan of seeing these concepts in action. Do you have any real-world examples of how these strategies have been successfully implemented?
I do. Let's take the oil and gas industry, for example.
Okay.
They face some of the harshest conditions imaginable, high salinity, extreme temperatures,
Yeah.
and constant exposure to seawater.
Yeah, those offshore oil platforms sound like a corrosion nightmare.
They are. But the industry has made impressive strides in mitigating these challenges by implementing a combination of strategies. They use specialized coatings on pipelines and platforms.
Hmm.
They implement cathodic protection systems, and they have rigorous inspection and maintenance programs.
So they're really throwing everything but the kitchen sink at this problem.
They are.
And what kind of results are they seeing?
A study by the University of Texas found that by implementing these measures, they've achieved savings of up to 20% in corrosion-related costs.
Wow.
This translates to billions of dollars saved each year.
That's significant.
Yeah.
It shows that even in those extreme environments, effective corrosion management can make a huge difference now. For a completely different example, let's look at the wind energy industry.
Okay.
They're trying to build a sustainable future, but I imagine those giant wind turbines, especially the ones offshore, are also prime targets for corrosion.
You're absolutely right. Those turbines are constantly bombarded by wind, rain, and saltwater spray, all of which can accelerate corrosion.
It's like they're facing a never-ending assault from Mother Nature.
They are.
So how are they dealing with this challenge?
Well, they've learned a lot from other industries that operate in home environments, like the oil and gas sector.
Right.
One key strategy they've adopted is the use of advanced coatings, specifically designed to withstand the rigors of an offshore environment.
So they're essentially giving those turbines a super durable shield to protect them from the elements.
Yeah.
What are these coatings made of?
They often use highly durable polymers or even ceramic materials that can resist abrasion, UV radiation, and the constant bombardment of salt water. These coatings are essential for extending the lifespan of the turbines and reducing maintenance costs.
It's like giving those turbines their own suit of armor, but coatings alone can't solve the problem, right?
No, they're just one part of the solution. Many wind farms are also implementing real-time monitoring systems using those smart sensors we discussed earlier. By strategically placing sensors on critical components, they can detect even the slightest signs of corrosion early on.
So it's all about being proactive rather than reactive.
Exactly, and that proactive approach is saving the wind energy industry millions of dollars in maintenance and repair costs. It also ensures the longevity and reliability of these clean energy sources, which is a win for everyone.
Okay, so we've seen how effective these corrosion-fighting strategies can be in very different contexts, but I'm also curious about what the future holds. Are there any emerging trends in corrosion management that we should be keeping an eye on?
Yeah, feels like we've only just scratched the surface here. But what about the future of corrosion management? Like, are there any exciting developments on the horizon that could really, change the game?
Oh, absolutely. There's some incredible breakthroughs in the works that could, revolutionize how we approach corrosion. One area that holds immense promise is the development of self-healing materials.
Self-healing materials. Okay, now we're talking science fiction. How does that even work?
It might sound like something out of a movie, but researchers are making remarkable progress in this field. Imagine like a material that can actually repair itself when it gets damaged by corrosion. So instead of replacing a corroded pipe or like a bridge support, the material could essentially fix itself.
Exactly.
That's amazing.
Yeah, these materials have tiny capsules embedded within them that are filled with this like healing agent.
Okay.
And when a crack forms or corrosion pit forms, those capsules release the healing agent, which then reacts chemically to seal the damage and restore the material's integrity.
So it's like giving the material its own built-in repair crew. That's so cool. Where are we seeing the most promising applications for this kind of technology?
The potential applications are vast. You
Mm.
think about areas where durability and longevity are absolutely crucial. Aerospace, infrastructure, even like medical implants.
Wow.
Self-healing materials could like drastically reduce maintenance costs
Mm.
and improve safety in a wide range of industries.
Okay. Self-healing materials are definitely high on my list of like cool future technologies. What else should we be keeping an eye on?
Another area that's generating a lot of excitement is the use of AI, artificial intelligence, and machine learning to predict and prevent corrosion.
It seems like AI is making its way into every field these days.
Yeah.
How is it being applied to corrosion management specifically?
Well, imagine feeding massive amounts of data about materials and environments and corrosion behavior
Yeah.
into this like powerful AI system.
Okay.
The AI can then analyze this data and identify patterns and then predict where and when corrosion is most likely to occur.
So it's like having an AI corrosion expert
Yes.
constantly monitoring and analyzing data
Yeah.
to find problems
It's-
before they even arise.
This would allow us to shift from a reactive approach to a truly proactive one.
Right.
So we're focusing our maintenance efforts on the areas that are most at risk and then prevent those small issues from turning into these catastrophic failures.
Okay. Yeah, that sounds like a game changer. It seems like we're moving towards a future where we can not only manage corrosion, but predict it
Yeah.
and prevent it.
Absolutely. And as these technologies continue to develop, we can expect to see even more innovative solutions emerge in the years to come.
Well, this has been an incredible deep dive into the world of corrosion. We've gone from understanding the basic science to exploring cutting-edge technologies that could reshape how we approach this age-old problem. Before we wrap up, I want to highlight a few key takeaways for our listener. First, corrosion is a costly problem that impacts virtually every industry imaginable. But the good news is it's a manageable problem.
Exactly. There are proven strategies and technologies available right now that can significantly reduce the economic and safety risks associated with corrosion. It's about making smart choices, selecting the right materials, implementing the right protective measures, and adopting a proactive approach to maintenance.
And we can't forget about the importance of staying informed about emerging trends. Self-healing materials, AI-powered prediction tools. These are just a few examples of the exciting innovations on the horizon that could revolutionize the field of corrosion management.
It's an exciting time to be involved in this field. We're not just talking about preventing rust, we're talking about building a more durable, sustainable, and safe future for everyone.
And on that note, we'll leave you with one final thought. Take a moment to look around and consider all the ways that corrosion might be impacting your world. It might be a rusty bridge, a leaky pipe, or even something as seemingly mundane as a scratched-up car. And then ask yourself, what role can you play in mitigating these costs, preventing these problems, and building a more corrosion-resistant future? Because with new knowledge comes the opportunity to make a real difference. Thanks for joining us on this deep dive into the surprising world of corrosion. We'll see you next time for another fascinating exploration.